Optical sorting cameras scan each fruit for size, surface, and color variations. Weight-based sorting systems classify custard apples into standardized groups, optimizing peeling efficiency and pulp yield in later stages.
Fresh custard apples arrive at the factory in ventilated crates, harvested at peak ripeness to ensure soft texture. Conveyor speed is carefully calibrated to balance throughput and gentle handling, avoiding pressure damage to the soft custard apple skin.
Excess surface moisture is removed using low-velocity air knives calibrated for custard apples, avoiding mechanical contact that could bruise the soft fruit.
Air bubble washing systems generate controlled turbulence around each custard apple, lifting soil and residue. A mild, food-grade sanitizing solution is carefully dosed to clean custard apple surfaces, reducing microbial.
Water pressure is precisely regulated to suit soft-skinned custard apples, preventing liquid from being forced into natural skin gaps and weakening the flesh beneath.
Excess surface moisture is removed using low-velocity air knives calibrated for custard apples, avoiding mechanical contact that could bruise the soft fruit. Slope drainage sections beneath the conveyor prevent standing water, keeping custard apples sufficiently dry for efficient peeling in the next stage. Conveyor spacing is maintained to keep individual custard apples separated, reducing skin-to-skin contact and surface scuffing after washing.
At the end of this stage, custard apples retain intact segmented skin, clean surfaces, and stable firmness.
As the skin loosens, the exposed custard apple pulp reveals clusters of small, glossy black seeds embedded throughout the soft flesh. The resulting custard apple pulp appears pale, creamy, and uniform, completely free from black seed particles.
Throughout the process, equipment geometry is designed around the reality that custard apples contain many small black seeds, not a single stone. Stainless steel transfer pipes are sized for slow-moving custard apple pulp, avoiding high flow rates associated with juice processing.
Ion control plates regulate shear force to prevent overprocessing, ensuring the custard apple pulp stays at 6. Any pulp showing excess juice dilution or thinning is automatically diverted, protecting.
8. Gentle paddles fold the pulp to equalize texture, enhancing the silky, custard-like mouthfeel unique to custard apples.
Temperature is carefully controlled to stabilize the custard apple pulp structure, preventing separation or liquefaction during handling.
This texture-controlled pulp is transferred to buffer tanks designed specifically for high-viscosity custard apple pulp, not beverage bases.
By the end of this stage, custard apple pulp achieves consistentness and
The adjusted pulp collects in buffer chambers as a uniform, opaque, creamy mass, holding shape briefly when deposited.
3 filter pour sizes are carefully selected to maintain the custard apple's naturally smooth yet spoonable texture, avoiding over-refinement.
7. Any material showing signs of excess dilution or transparency is automatically rejected, protecting the signature creamy density.
8. Gentle back pressure valves stabilize pulp movement, ensuring custard apple pulp never becomes watery during filtration. 11. Stainless steel piping dimensions are optimized for slow, paste-like custard apple pulp, not beverage transfer.
By the end vine filtering, custard apple pulp achieves consistent distribution, stabilization,
Така.
Gentle circulation prevents sugar settling, ensuring custard apple pulp remains evenly sweet throughout the batch.
10 viscosity checks confirm the mixture stays spoonable and paste-like, not pourable like drinks or dessert soups. The mixing duration is optimized to fully integrate sugar without breaking down the fibrous matrix of custard apple pulp.
No water, milk, coconut cream, or starch slurry is introduced, maintaining a formulation based solely on custard apple pulp and sugar.
After heating, the custard apple paste moves slowly toward homogenization under controlled pressure suitable for very thick materials.
9. Low shear homogenizers refine microtexture, breaking small lumps while keeping the paste thick, creamy, and non-liquid.
Homogenization does not create flow. The custard apple paste remains mound-forming rather than stream-forming.
11. Visual checkpoints confirm no translucence, no foam, and no rapid movement, reinforcing correct paste structure.
The cooked and stabilized custard apple paste cools slightly within closed systems to lock texture before filling.
The processed custard apple material exits thermal treatment as a fully refined white mass.
Gradual cooling stabilizes the ivory white custard apple paste, locking color and density while preventing darkening, yellowing, or surface separation.
Inline inspection verifies that no skin, rind, or fibrous peel particles are present in the filled custard apple dessert.